Hello friends, this is lecture number 4 of integral transform, and here we're going to discuss about definition of Fourier transform, and we're going to learn how to find Fourier transform. We're going to take some solve problems. Okay, so we're going to solve this question: find the Fourier transform of these two functions, right? So just after the definition we're going to solve this. I'm going to show you how to solve these kind of questions, right? So before we start, please subscribe the channel, hit the thumbs up button if you like my videos, and also share with friends. Inspire me to create new contents for you, and help me to grow my channel. So now let's start. And one more thing, if you want to follow me, then this is my Insta ID ozalukazit123. Just you can follow me on Insta. Okay, so let's start. Fourier transformation or Fourier transform. So what is the definition of Fourier transformation? So let me write the definition here. So Fourier transform of a function, suppose the function be f of t. Fourier transform of a function f of t is given by capital F, means Fourier transform of the function f of t is equal to minus infinity to plus infinity, integration of the function f of t from minus infinity to plus infinity, not only f of t, integration from minus infinity to plus infinity f of t e to the power minus st dt. So here is the definition of Fourier transformation. So just wait, let me use another color here. So this is the Fourier transformation, definition of the Fourier transformation. Let me write it here. Just wait. This is the definition, right? So now let us solve a question. So that is what here, the find a Fourier transformation of these two functions. So first one is e to the power minus mod t, and next one is n into e to the power minus alpha x square, and where n and alpha, these two are constant terms. Okay, these are constant. So now let us solve one by one. So first let us solve this one. Okay, solution of a, where the function, given function is, let me take f of t here, e to the power minus mod t, right? E to the power minus mod t. Now by the definition of Fourier transformation, Fourier transformation of capital F, Fourier transformation of f of t, which means the by the definition of Fourier transformation, we got minus infinity to integration from minus infinity to plus infinity f of t e to the power minus ist dt. So here the f of t is nothing but this, e to the power minus mod t. So we're gonna put that one here, minus infinity to plus infinity. Instead of f of t, we're gonna put e to the power minus mod t, right? Then e to the power minus ist dt. That's what we have got. Now we know that the definition of modulus function mod t, that's gonna be equal to, you know, minus t for t less than equal to 0, right? And plus t for t greater than equal to 0. Now here you see 0 is neither positive nor negative. So here, so 0 is the boundary point here. You can write this way as well. Just wait, you can write the less than 0, then positive t for t greater than equal to 0. You can write that way also, same mean. So then if that is the case, then we can write minus mod of t, that's gonna be plus t for t less than 0, and minus t for t greater than equal to 0, right? So if this is mod t can be defined this way, right? And if you multiply minus, then it's gonna be plus, it's gonna be minus. So hope you have understood these things, right? if that is the case, then what we can write, here 0 is the boundary point, so if you integrate it from minus infinity to 0, then for minus infinity to 0, as we know, for less than 0, so minus mod t is equal to plus t. So that's why what we're going to write here, e to the power t. So this is going to be plus t, right? For less than 0, minus mod t is equal to t for minus less than less than 0. So as we are taking less than 0, so it's going to be the minus infinity to plus 0, plus, not plus, 0 is just 0. So minus infinity to 0, right? We can write e to the power minus ist dt. We can write this way. Then plus, then 4 greater than 0, 4 greater than t greater than equal to 0. We know that minus mod t is equal to minus t. So here for 0 to plus infinity, we can write this is equal to e to the power minus t, e to the power minus ist dt, right? That's what we can write. So hope you have understood this. So now this is the Fourier transformation of the function f of t, or Fourier transformation of this e to the power minus mod t, right? So now so let me integrate. So what we can do now, minus infinity to 0 e to the power t minus ist, that's what we have got. We can take t common, and on taking t common, what we can write here, t into 1 minus is, that's what we can have, right? 1 minus is dt, and integration from 0 to infinity e to the power, you can take now minus t common, then you're gonna get 1 plus is dt, right? So hope you have understood this. Sorry, I missed a plus sign here. That should be plus, right? So this is what we have got. This is the Fourier transformation of this. So now let me copy this and let me go to the new slide. Let me copy this and let me go to the new slide. Okay, so here you see, so this is the last step we have got. So if you integrate this, so integration of e to the power mx dx is nothing but e to the power mx by m. If you apply that, then it's gonna be e to the power t into 1 minus is divided by 1 minus is, and we are integrating it from minus infinity to 0, then plus here we're gonna have minus t. If you integrate this, then you're gonna have minus t 1 plus is by 1 plus is, integration from 0 to infinity. And if that is the case, what we can write, if you put here 0, then e to the power 0, that's going to be 1. So 1 by 1 minus is, then minus, then if you put this minus infinity here, then it's going to be e to the power minus infinity, which is going to be 0. So 0, then plus. Now let's put here minus infinity, put here infinity, that's going to be e to the power minus infinity. So it's going to be e to the power minus infinity, which is going to be 0. So 0 by anything is 0, then minus. So sorry, I have missed one thing, this minus, so here it should be minus. Okay, then if you put 0 here, then it's going to be e to the power 0, which is 1 by minus 1 minus 1 plus is. That is what we have got. This minus becomes plus, right? So got it, make it positive. So that's why if you take LCM, then here you're gonna have 1 minus is into 1 plus is, then 1 plus is into 1 plus is, then plus, so just you can ignore these zeros, right? So that's why you're gonna get this, right? So 1 minus is. So here these two cancels, right? So what we're gonna get here 2, and here we're gonna have 1 square minus is whole square, and I square is minus 1, s square is s square. So here we have negative, so minus minus, that's gonna be plus s square, right? So hope you got it. So that's why this is gonna be equal to 2 by 1 plus s square. So this is the answer. This is the Fourier transformation of e to the power minus mod t, right? This is the Fourier transformation of e to the power minus mod t. So now let's go to the next function. So we have solved this one, right? Now let us solve this one. Okay, let me take a new slide. So now let's find the Fourier transform of this solution. So here the given function is here function of x, f of, don't write f of t now, we have variable x here, so f of x. So e to the power, sorry, n into e to the power minus alpha x square, where n and alpha are constants. These are constants, and by definition the Fourier transformation of f of x, so we can write minus infinity to plus infinity f of x e to the power minus is, now we have to write x dx, right? So that's what we have. And let's put what is f of x here, let's put this one here. So then what we can have, minus infinity to plus infinity, n can be written outside as it is constant, so minus alpha square x square e to the power minus is x dx. So now apply the laws of indexes, then we can have n into integration minus infinity to plus infinity e to the power minus alpha x square minus is x dx. That's what we're gonna have, right? So now, so what we can do here in this case, so let's take this part. So what we have here, minus alpha x square minus is x. So if you take alpha common, let's take minus alpha common, then what we're gonna have, we're gonna have x square plus is x by alpha. That's what we're gonna have, right? So now using the completing square method, here it can be written in this form, x square plus twice ab plus, sorry, a square plus twice ab, a square plus twice ab plus b square, or maybe minus. So let me convert in this two form. So here we have positive, so it's going to be converted into this form, right? So how to do that? Here you see minus alpha within the bracket. As we have x square, then let's make here let's write a 2 into a. Instead of a we have x, then b we can write here is, x is already written, this x is written here, right? So then as there is no 2, that's why let it be divided by 2. So that's what we can have. Then we have alpha here, so that should be alpha, and this should be considered as b. So we can have is plus 2 into alpha whole square. So let me use here curl bracket. So this term was not present here, so that's why we're going to eliminate it again. So minus is by 2 alpha whole square. Now it is balanced. Now what we have got here, minus alpha, and here you see from this we have got x plus is by 2 alpha whole square minus is by 2 alpha square. We have got this. So now let's use this result here. Then what we can have, Fourier transformation of the function f of x. F of x is nothing but n e to the power minus alpha x square. That's going to be equal to n into integration minus infinity to plus infinity e to the power. Now we have got this power is in this form, so let's put it minus alpha. So let me write the alpha properly. Minus alpha into x plus is by 2 alpha whole square. Then here we have minus is by 2 alpha whole square. Right, now you see, if you square this, then what you can have, you should have minus alpha integration minus alpha into x plus is by 2 alpha whole square. Then it's gonna be plus I gonna be minus 1. That's why we have got this minus become plus on squaring I, right? So s square by 4 alpha square, that's what we're gonna have, right? If you multiply this minus alpha with both the term, then this is gonna be equal to, so let me modify it, minus alpha into this, then minus alpha into this, then alpha cancels alpha square, so it's gonna give you s square by 4 alpha. That's what we're gonna have, right? So hope you have understood this. So instead of this, we can write here minus alpha into x square, sorry, not x square, let me write the alpha properly, sorry, minus alpha into x plus is by 2 alpha whole square minus s square by 4 alpha. That's what we're gonna have, right? That's we have got into dx, right? So now what we can do, we can write this way. So e to the power this one minus this one, that can be written in this way, that e to the power this into e to the power minus this, we can write this way, right? And this part is constant, that can be taken out of the integral. So that's why what we're gonna have, n into e to the power minus s square by 4 alpha integration from minus infinity to plus infinity e to the power minus, we can write root over alpha x plus is by 2 into alpha whole square. We can write this way, dx, right? So this alpha can be written as root over alpha, right? Root over alpha square, we can write that way, right? So we have got this. So hope you have understood this. Sweet. So now let me copy this result and let me go to a new slide. Okay, let me take a new slide, just wait, give me a second. So here is the last step we have got, and let me cut it. This part is not needed now. So Here is what we have got. So now let us take, so what we're going to do here, let minus root over alpha, so ignore the minus sign, just root over alpha x plus I s divided by 2 alpha, this is equal to suppose t. Now let us differentiate with respect to x, differentiating both sides with respect to x. So this is going to be alpha, derivative of x is 1, and derivative of this part which is constant, that's going to be 0. So we're going to have dt dx, that's what we have got. So that means dx going to be equal to dt by root over alpha, right? So let us make the substitutions, and so it's going to give you n as root alpha is constant. So instead of dx we supposed to write this, and this root alpha is constant, so it can be taken outside the integration. Then e to the power minus s square by 4 alpha minus infinity to plus infinity, then e to the power minus, and this part we have considered as t, so we're going to write here t square dt. So dx is replaced by dt by root over alpha, which is taken outside, right? So hope you have understood this. Now you see that we know the definition of from the definition of gamma function, that gamma of n is given by this is the definition of gamma function. Now here you see, if you replace x by t square, then what you're gonna have, so x is equal to t square, then which is gonna give you, if you differentiate with respect to x, then you're gonna get 1 2 into t dt dx, and which is nothing but dx is equal to 2t dt. That's what you're gonna have. So in that case this becomes so 2 is taken outside the integration, 2 to infinity 0 to infinity e to the power minus t square, then t to the power twice n minus 2, right? So here x is replaced by this, and doing so we're gonna have this. So then dx is replaced by 2t dt, this 2 is taken outside, right? So we are not going to write the 2, this t into dt, and if you multiply this t and this one, then you're gonna have the here minus, right? That's what we're gonna have. Okay, so here you see, if you put n is equal to half, then gamma function of half, then we're gonna get 2 into integration from 0 to infinity e to the power minus, instead of t square remains t square, and t to the power 2 into, here we're gonna have, instead of n we have put half here, minus 1 dt, and that's gonna be equal to 2 to infinity, 2 into integration from 0 to infinity. So let me write here, just wait, so e to the power minus t square, so here 2 gone, 1 minus 1 0, so here we're gonna have 2 t to the power 0, which is nothing but 1, this is equal to dt. Now you see here we have minus infinity to plus infinity, so we can make it. So here you see, as we have got gamma function gamma of half is equal to this one, 2 integration 0 to infinity e to the power t square dt. So here you see, as it is e to the power t square, that must be a even function. Okay, e to the power minus t square, that will be an even function because this is equal to e to the power minus t minus t whole square. Both are same. That means in this case f of minus t is equal to f of t. So this is even function, right? So for even function we can write integration from minus a to plus a f of x dx is equal to 2 integration from 0 to a f of x dx. We can apply that, and if we apply that, then we can write here n root over alpha e to the power minus s square by 4 alpha, then 4 alpha integration. Here if you apply this rule, then what you can do here, let me write it properly, just wait. 2 into integration from 0 to plus infinity e to the power minus t square dt. That's what we can write, right? And now you see, let me copy this result, that is Fourier transformation of n e to the power minus alpha x square and also gamma of half is equal to this. From these two, here you see, we can replace this by gamma half, and gamma half is equal to root pi. So that's why what we're gonna get, so we're gonna have this, right? So this is what we have got. So this is the Fourier transformation of the given function, and here you see this is equal to gamma half, which is equal to root pi. We have got that. If we use this result here, then what we're gonna have, then we're gonna get this, right, which is equal to, right, root pi. Its value is equal to root pi. So we can write this one in this way, n into root pi by alpha, under root pi by alpha, we can write this way, e to the power s square by 4 alpha. So this is the Fourier transformation of n e to the power minus alpha x square. So this is the answer. So hope you have understood. So if you have understood, please subscribe the channel, also share with your friends, like the video, and help me to grow my channel, inspire me to create new contents for you. So see you in the next video. Thank you for watching.